Let's do it.
Well, welcome everybody to the Past Performance Virtual Chapter. My name is Carlos Bassi, and I'll be your moderator today. If you want to reach the chapter, we have many ways to reach us, our website, our email, and that sort of thing. So feel free to do so if you need anything. Next slide, John. If you need any technical assistance, basically the audio is only available through your computer speakers. There's no dial-in number, and you're only in listen mode. And one question we get every time is the session recorded? We always record the sessions. The session's being recorded, and we post them on our YouTube website. So if you have to miss the session or you get part of it, you want to see the recording, it's on the YouTube site. Next slide. Thanks to our sponsor, SolarWinds. They allow us to give away an Amazon gift card, and they've been a great sponsor for us for many years. PASS has many virtual chapters. This is just one of them. They have virtual chapters in other languages and for other areas, big data, business analytics, many more. So make sure you check those out and participate in the virtual chapters. SQL Saturdays are great events that happen around the world, and the upcoming SQL Saturdays for this next month are listed on the screen. If there's one in your area, make sure to check that out as well. And there's a 24 hours of PASS coming up on May 3rd and 4th. Make sure that you sign up for that and register as well. 24 back-to-back sessions or 12 or two 12-hour days are usually the way those are formatted. There's again a lot of great free training coming from PASS and PASS speakers there. And make sure if you want to get involved, volunteer with PASS. PASS has many volunteering opportunities, ways to get involved, virtual chapter, SQL Saturdays, users groups, so get involved if you can. And next slide, I more or less said that. That's the way you can reach PASS. Now let's just get to our session today. The title of the session is Why Did My Execution Plan Change? Introduction to Query Store. It's presented by John Sterrett. John's a SQL database expert and speaks at many events. I've known John for several years, and he always does a great session. And I'll let John take it over and introduce himself a little bit more.
All right, thank you, Carlos. So today's talk, we're going to go over execution plans and go over why they change, and then show you quite a few ways on how you can fix this. So I know a lot of people aren't using 2016 yet, so we're going to go over history and show you exactly how you can go about resolving some of these issues, even if you're using SQL Server 2005 all the way up to 16 now. So just quickly a little bit about myself. Carlos went over the virtual chapters. I actually am the founder and organizer of the High Availability Virtual Chapter. So anyone's never seen me before and has attended, it's nice to see you here as well. I'm the founder and owner of Procure SQL. It's a small niche consulting company based in Austin, Texas. We focus on performance tuning, high availability, and basically anything on the relational side here. Actually, coming to you today from the conference room over in our new office here in North Austin. I'm a data platform MVP with Microsoft certified, and also wrote a book with Tim Radney a couple years ago on backup and recovery there. So anyone who wants to contact me, please feel free to use any one of these methods here. I am pretty active on Twitter. If anyone's watching, they like the session, feel free to tweet about it, and if you have questions later, do so as well. So I am an attendee just like you guys. I attend lots of conferences, virtual sessions, so when I present, I tend to make everything I do online available so that way you can access it, so you don't have to cram and write a whole bunch of notes. So the scripts, everything that we're going to go through here today, you can get your hands on and play with when you have some free time. So to start here, we're going to focus on what is the life of an execution plan. So when you execute a SQL statement, here's basically the nuts and bolts about what happens with your execution plan. So as you're executing a SQL Server statement, the first thing the optimizer is going to do is going to say, okay, do we already have an execution plan here that exists? So if it does, one of the things in most scenarios that makes SQL Server great is it will reuse it, and that'll be a great thing for you. So if that execution plan exists, in the plan cache, which will be your memory, it's going to go ahead and use it. Now, if it's not, so if this is the very first time that you're running this block of code, whether it's procedure or ad hoc SQL statement, or maybe you've done something like recompile the plan, it's going to go ahead and build an execution plan. And when it does that, by default, it's going to take the runtime variables of that first time that you execute the plan, and it's going to assume, that's what we're going to build a plan for. That's going to be our guide of what we're going to use for this execution plan. So basically, it's going to take that runtime variables for the first time you use it, build a plan based off of that. Then it's going to put it into the plan cache, so that way it can reuse it so you don't have to recompile and you can save a lot of CPU. So the key thing to start off to make sure everyone knows here is as you're building your statements, it's going to check to see if it exists. If it does, it's going to use it. If not, it's going to use those first runtime variables, build the plan, put it in cache so it can reuse it, and then it's going to use it for you. That's very key to know because for the most of the time, this is going to be great, but we're going to go ahead and take a look at some examples where that may not be ideal for you, and we're going to show you some things you can do from 2005 all the way up to 2016 for that. So how do we detect when a plan even recompiles? There's a couple different ways on how you can do this. You can use Profiler, or what I would like to say server-side traces, because I never really like to run or see people run Profiler out there on a production box. We have extended events as well. And what we're going to focus on mostly today here looking at is actually some DMVs and then also query store here towards the end. So there's also a lot of reasons why your execution plans can be recompiled or basically fall out of cache. So now that we know exactly the workflow of how a plan gets in cache, a question a lot of people ask me when I work with them is, when we're looking, why do we see the execution plan is different over time? So we know we have a list of statements that are important to us. And when we're actually periodically looking, we can kind of see that plans are different. Well, basically, this is a scenario where, as we've mentioned, when we recompile the plan at the variables at execution time are going to get pinned and used to build the plan. So as you have different data for different values, this can lead us to actually build different plans. And we're going to go through some demos of that. But some reasons that your plan can fall out of your plan cache in memory are listed here, and there's a lot of them. And this comes pretty much from books online. So I'll let you guys go ahead and read here, but the key thing that I want to point out is there's one thing that's not listed here, and that's just the fact that in your workload you have so many plans, you can only keep so many in memory, so they fall out, which is very, very common. So as a DBA, right, if we get pulled into a scenario where we need to force plan, so we know we have a good plan, how do we keep that good plan to constantly be used? Here's the list of things that DBAs tend to try if they get into this battle. And I kind of start from top to bottom on what I tend to see a lot more out in the field. So a lot of people will first start with, hey, it's a procedure, I'll just do SB recompile until it's a recompile the procedure. Or maybe if it's a statement, I'll add the option recompile to the hint. So that way it's going to force it to recompile when it runs. That's basically, all that's doing is just invalidating the plan for you. So the next time it runs, if you control it and you run it right after that, you can kind of force it to to build a plan towards how you like based on what parameters you're using. It's not the best method out there, but it's one I see a lot of people start with because it's easier for them to understand and kind of control. So next, based off of that, is I'll see quite a few options like optimize for unknown. So this is where you have parameters in your statement, and you basically are saying, we got so much data skew. There's a lot of cases where the filters we're using only have 1 row. There's cases where there's 1 million, or we just want to make sure we have the same plan so we get a consistent kind of execution plan and work for the statement over a large average of possible values. So there's good and bad with that, where it will get you basically the same plan, but then basically to kind of figure out its statistics that it's using to build the execution plan, it's just going to take the number of rows in the table and divide it by distinct values and use that. So it's actually completely ignoring statistics that you have on the columns and indexes, and it's just going to go ahead and use that formula to kind of figure out, okay, what should we use over a long period to get us the same plan. Another thing I mentioned is add an option recompile, which basically will tell you to recompile that statement every time it runs. So that can help get you a really good plan, especially when you got a lot of indexes on the table, but there's CPU overhead for that too. Another one is you can specify a value. So if you know your data well and you know what most likely is going to occur, you can use the option forcing a value in there too. So another things I see DBAs do, especially when they have direct access to the code. So for example, if you're working in a developer shop and you have procedures and you guys are actually able to change the code, I'll tend to see DBAs try to force table or index hints to do certain things that they want, which definitely could be a good thing as long as they know the data and how it changes. The other one I see and I hope gets used more in those scenarios is people actually changing the SQL code there. So maybe you have some code that isn't optimizer friendly and you can change it to be more optimizer friendly. The last one here is one I see very rarely out in the field. And in fact, even when I help some of my clients doing interviewing for our senior level people, I'll ask the interviewees what they know about plan guides, and I always tend to see very, very little. So even if you're in a scenario where you're working with third-party applications and you don't have control of the code and you can't change the code, you can actually use this pretty cool feature called plan guides to force the code to actually do something that you want it to do, which we're going to go over in a couple of demos. So with that, we'll go ahead and we'll jump into our first set of demos here. We're going to go over exactly how we can capture execution plan and also their usage statistics. So that way we can detect, hey, we have statements where plans are changing, so we can focus on them. Then we're going to go ahead and identify on queries and changing the plans, and then talk about how you can actually force this with plan guides and go through a few examples. All right, so I restored our little sample database here, and what I've done today, since we only have an hour, is I tried to take something that's pretty hard to identify, do analysis on, and fix into a very short, simple example that hopefully everyone can follow here. So we're going to have real basic one table, one query, show you how the plans can change for it, and do some basic analysis on it. So I've already restored a database to get us prepped, but here I'm just going to walk through so everyone can kind of understand what do we have here in place. So we have let me make sure we're using our new database here. So we have one table here where basically there's two different ID columns in here and some text. This is our sample table that we're going to play with here throughout the demo. I have a second table here called store plan. This is just going to store some metadata stats about how that table is being used and the statements that are using it and the plans that are using it that we're going to capture as part of our analysis here. So even if you're on 2005, you can kind of take this code, run it periodically to grab some of this data so you can use that as a tool to help you. So here we created the data for our table. So the very first thing that I end up doing here is looping through 10,000 times and just creating a singleton record for each of those IDs. So 1 through 10,000 will only have one single row in it. And then we create some data skew here. So I take that first value and I add 100,000 rows. So if the ID or ID2 equals 1 here, then we're going to have 100,001 rows. If it's any other number that we have data for here, it'll just be one single row, which we'll easily be able to see by this query here. So once again, just to point out, because this is knowing our data in this case, knowing our skew, trying to keep an example very easy for everyone to follow here. We have our ID1 and ID21. We have 100,001 rows. Everything else going down here, you can see we have one single row here. All right, we have indexes for each column there, and then we have one simple stored procedure, which is just get me everything based on those two parameters there. So to get started here, now that we kind of know how this is set up, we know the data, and in our case here, this is all static. We're not changing it. These are all things you would want to know and factor in towards making decisions towards how you would want to freeze plans for a long term. We want to make this simple. Start off here. I'm going to run ddcc free proc cache. This is not production. What I'm doing here, for anyone who doesn't know this command, is I'm taking all of my plans in memory and I'm throwing them in a trash can. So this is something you really don't want to do in production, especially while big workloads are running. But we're doing that to get a nice starting point here, and then I'm turning set statistics IO on so we get those metrics. And then I also have our actual execution plan here highlighted, so we'll get that. So we know if ID equals 1, we have 100,001 rows. We're going to go with a different ID here to run our very first statement. Remember, we cleared our plan cache, so as we run this, the optimizer is going to say, no, we don't have a plan in cache, so let's build a plan based off these values. So we do that, we see we have our one row as expected, and we have this execution plan here. So a lot of people that look at execution plans, they always start from the top right and go to the left. So today, I hope one thing that everyone learns from watching this presentation is it's actually very good to focus and see the properties of your select object here, because this is where we're going to see some key bits of information like which actual parameter values were used at compile time to build this plan that we're using. And also if we're using plan guides, you'll see information like that. So it's actually really good to look at your execution plan going in both directions and not just focusing on right to left here, which we'll look at in a bit. So one thing a lot of people look at when they look at plans, they look for certain key things and focus on that. So as an example, here we have what's known as a RID lookup. So this means that there's not a clustered index on this table, and we're having to do a lookup to pull additional information because it's not included in our index. Now, we're only actually doing 3 IOs here, so this really isn't that bad. If we had a lot more data here, this might be a different story. But I want to point this out here because this is a pretty small statement where we're doing a index seek. We're doing what's known over here as a nested loop. For any developers out here on this call, this is pretty much the same thing as just saying a for each loop, right? For everything that's up here coming in, we're then going to go down and do what's down low beneath here. So another nice thing, as I mentioned, if we look at our properties here, this is where we're going to see some really good information about the actual compiled parameters and runtime. Since this is our first time running this procedure since we freed our cache, these two will always be the same. But as we're running it, now that it's in cache, we'll see different runtime values in here, which is all important to know. So as I already mentioned here, you can see we have 3 reads. So this is about as good as you're going to really want to get this. Now let's look for our bigger set of data. So this is going to use ID equal 1, which is our 101,000 rows. So because this plan is already in memory, we're going to use the exact same plan. Now, a misconception a lot of people may think is if you hover over here and look, you're going to see that, oh my gosh, we have 101,000 rows here, but we only estimated one single row. So our stats have to be bad. The stats are not good. That's actually not the case at all. Our stats are perfect. The reason why we estimate one row is, if you remember, when we just ran this, we ran this for parameters that only had a single row as it looked it up. So as it built the plan off of those values, it's what built this estimation here of one single row. All right, if we go over here, this is where when we look at these, we're going to see some differences here. So most of the time this is a great thing, but here's kind of an edge case that happens a lot more as your data is skewed and you don't usually have the same rows for all the values that you have there for your columns, where we're actually going through here and this is 101,000 rows and this is just 1. So here we have what I would call a big red flag, and that's the fact that we got a big arrow here pumping into my for each or nested loop, which means for 101,000 times, we're going in here and pulling data here. So there you can exactly see how a plan can change and why it changed. The next thing we're going to do, I mentioned we had 2 tables, is we're going to pull this data and store it into a table that we can look at. So we'll go over this a little bit in more detail here through our next execution, but the main thing to notice here is we have some good stats. We have ways to 2 separate ways here to identify the SQL statement and the execution plan, which we'll talk about a little bit more. But we can see in this example that I tried to simplify here, we just ran it twice. Once for our best case and once for the worst case. And on an average here, we can see how much CPU was used, logical reads duration, and we can get the execution plan. So another thing to point out that some people tend to not understand is when you're looking at the DMVs and you're able to grab the plan that's in cache, this is actually an estimated plan. It's not an actual plan. And an easy way for you to see that is the only thing you're going to see in here is your compiled value. You're never going to have the runtime value because this isn't an actual execution plan. It's estimated. So we have that. We stored it in our table. So now we can look at this from the opposite end of the spectrum. So before you saw me run ddcc free proc caching here, and that got rid of every single plan. Now, what if you just wanted to get rid of one? Well, we can easily do that by just grabbing our plan handle, which we have here, and putting it in our parentheses here. So instead of deleting everything now, we're just going to delete the one that we want to get out of here. This is not a bad thing to do in production. If you have the plan, you know your one you're doing, you're just freeing out one single one. So now we're going to look at this from the opposite end. The first time we run this, now that we pulled out our plan, we're going to go ahead and take a look at the big data skew. So ID1, which has the 100,000 records here, we're going to run this and we're actually going to see a different execution plan. So let me get off the tooltip there. So here we see a table scan, and some people will just look at that and say, oh, this is horrible, we need to add some indexing on here. Well, when you're actually going to run a query that's going to get you, 99% of your data of the whole table, a scan is actually going to be a better thing for you than doing a whole bunch of seeks, which we can see here from looking at our I/O, because before we were at, as we can see up there, 100K. Now we're down to 24. One thing I definitely want to keep everyone aware of here is this is scanning the whole table. So as this table grows, this is not going to scale well, and this is just going to go up and up. So you definitely need to know your data and how your data is going to change. But the point here is for this use case, we have a different plan, and this is actually much better for this parameter here. So a question you would want to know is, how many times exactly in the real world are we going to use this parameter and get this data set? Is it enough for us to where we would want to focus on having this plan be used for everything or use the other plan? And we're going to look a little bit into that. So the plan is cached. We're going to do the exact same thing now, just with one of the other values. So we return one row as expected here. Instead of having 3 reads, we now have 243, and the reason why is that's how many pages are in the table, and we're scanning across the table. So once again, when we go here, look at the parameters. We're going to see exactly what we were expected here before. When we compiled this, we had the opposite. We had 1. Now we have 500. So now we're not doing the key lookup, and we're doing a table scan, which is worse for us, we think, right? So we're going to go ahead and do the same thing, grab and insert here. So now we have some good data. We can start to do some analysis. And once again, we're keeping this very simple, very easy. We have only 2 plans that came in, and we have the best and worst case that ran for both of them here. So first thing that we want to look at here is, how do we identify these? How do we know we have a different plan? And for anyone that's been working with SQL 2005, here's an interesting gotcha. So we would expect, when we look at SQL handle, which is the only thing we had in 2005 to identify our statements, we have the same value for the SQL statement. Makes perfect sense. This is a hashed value. The text didn't change. We expect the same. This is where you get thrown off. Even though we know we have different execution plans, the plan handle is the same too. Not so fun here. This really kind of threw me off when I started with this. But 2008 and on, we have query hash and plan hash. And the great thing here is we can see, because we're constantly collecting this info, we have our query hat plan here with different values. So we can easily see, okay, here's a case where the plans have changed. So we can start to dive in to figure out why and what all has changed. So here we have our cache time, so we know when it got into cache, last time it was executed. But here, as I mentioned, we got our best case, worst case. So if we're just going to go off of this as our analysis, it's probably, at a first glance, looks like, well, we'll just go ahead and go with the second one, because it's better, right? This is where collecting good data, knowing your data, doing good analysis really helps you. But in our case, to keep this simple, we look at the second one and we think, okay, this is good. So if we were going to force one of these plans, we'd probably go with the second one. And just to show you again here, we have our new plan here, which was the table scan. So at a very high level, this is a way on how you would understand and learn how your plans are changing, be able to capture the metrics, and start to make a decision on maybe, okay, which type of plan would we want to try to force? And you could do this from 2005 all the way to 16. So before 16, how do we force our plans? If you have access to the code, you've got a lot of options, right? You can add some recompile hints, which we talked about, optimize hints, force indexes, force table, or you can even rewrite your code maybe to be more optimizer friendly. The question that a lot of people don't understand is you still have some options even if you're working with a third-party app, and they will tell you instantly, you lose all support if you change any of our code or any of our indexes. Well, we have this nice thing called plan guides, which we're going to go into, to where this doesn't change the statement at all, the indexes at all. It's just an extra thing that you can use to where the optimizer can detect, hey, I have a plan in my plan guide. Let's use that. So it's a nice way for working with third-party applications, or maybe you even have a in-house application you built, but there's so many indexes, the optimizer is just picking a good enough plan and not the one with the best index. This is a way where you can use plan guides to force that. So we're going to look at a real easy example here. This is our stored procedure in here. And basically, most people who have stored procedures have multiple statements in it. So this allows us to find a statement in the stored procedure and be able to apply a hint to it. So in this case here, to start off, what we're going to say is we know our app. We know the data, we know how it's skewed, we know how the data is changing, and we want to always optimize for this value of ID equals 500. So we're going to go ahead and run this. Notice we didn't change the procedure, we didn't touch an index, we didn't touch anything with our schema other than adding this new plan guide. First question you might wonder is, okay, how do I know if plan guides exist? Well, we have a nice system view that we can look at to see that. And here we can see we just have that one we just created here. We can see that the object is scoped because it's in a procedure, and our exact hint, that's there too. All great stuff. So now I'm going to go ahead and free everything out of memory. We have our plan guide that we just created for 500. So anytime we compile, the plan guide is going to say assume 500. So now I'm going to go ahead and run this with our big data, right? Our ID equals 1, which has the 100,000 rows. And because we have our plan guide here, we're going to use that big key lookup, which is, once again, our worst case scenario that you're seeing here. So as I mentioned, you want to focus on the select because it has some interesting properties that are helpful for you. If you're using plan guides, this is how you can tell from the execution plan that the plan guide is in use, only by going to the select and looking there and seeing this here. So same thing here, even though this is the first time we ran this, putting it in memory here, the nice thing to see is here we told plan guide optimize for this value, so even though this is the first time it's running, it's doing that. So if we come here and we can see that this is our bad case. So notice this is another interesting, easy sign to tell this isn't a good plan for these values. We're actually doing more page reads here than the amount of rows we even have in that table. But we'll go ahead and we'll run this for our best case here. And we can see we're at 3. It did our nested loop here, which is our best case here. And same thing. We go here, we see our plan guide. We know that this is using our good old plan guide. So now I'm going to go ahead and drop this. So we're not going to have our plan guide anymore. We look here, we'll see we don't have any. Because I showed you how we can optimize for a value, we can also tell it to optimize to force to use an index. And when you're using indexes, probably your first thing that you're going to think about is, well, what happens when that index gets dropped? And the answer actually changes based on the version of SQL that you're using. So I believe way back in 2005, it would throw an error. In later versions, like I've seen this where it actually will return an empty result set, even though there's data. So this is something you definitely want to test and look for your environment here. So the first thing to do to test is, once you have a plan guide in use, there's a function here called fn validate plan guide. So if you had any plan guides and it had errors, so like for example, we built it on an index and that index got dropped, we would actually see data in here showing that it's failed. So we're going to go through that example. So we're going to go ahead and recreate a plan guide here. And we're going to go ahead and create the same thing. The only thing that's really changing is our hint here. So we're going to tell it to our option on table. This would be query store. If you had an alias for the table, you'd put that here. And then we're going to say the actual index here, so IDX2. So we're going to want it to use that index here. So we got that. Now we're going to run it again here for the small version. And you'll see here, we are using IDX2 because we forced it to use it by using our option in our plan guide here. So just to validate and prove that, here we can see that we dropped the plan and rebuilt it, so we're using our ID value there. But because we have our plan guide there, we're going to force our index 2. So let's go ahead and drop it. We're going to go ahead and drop that index. And now the question you may be wondering is, what's going to happen here? Now that we have a plan guide, we're forcing it to use an index that no longer exists because we just dropped it. So on 16 here, SQL Server 2016, we're going to get this here, and it's still going to run. We still get our result set that we expect. So we do this here, we run, we look at our properties, and this is how we know a plan guide was not used. We don't see plan guide over here. Now you can use an extended event session or profiler to pull that and see the failed attempt as well. But we're going to go ahead and we're going to look at that function here, fn validate plan guide. And here we can see that this failed because our index here didn't exist. So if you wanted to protect yourself against this, right, we're going to go ahead and create our index back. And then another thing you may be wondering is, okay, what happens now that we have our index? Good old Java. Now that we have our index back. So now that our index is back, we don't have to do anything. The plan guide's still there. It's going to see that it can use it, and you're going to see that the plan guide is back in here. So how do we help ourselves from not shooting ourselves in the foot and deleting an index that's used by a plan guide? Your option here, which you want to be careful about, is you can have a transaction here where you would say drop it, but then roll back if it actually would cause an error here. So keep in mind that by doing this, you have the potential of a lot of log overhead for dropping the index and then basically rolling it back. But this is one way how you can prevent yourself from shooting yourself in the foot here by deleting that index. And so with that, we'll go ahead and drop our plan. So another thing that we'll look at, because it's a myth that a lot of people don't realize, is you can even use plan guides if you're using SB Execute SQL. So here's just another interesting example that's taken from the real world but kind of applied to our table. I have a case here where we have with no lock, and even at the same time add option optimize for unknown. And we're going to go ahead and run this so we have it. Oh, let me change over to our query store. And then now I'm going to go ahead, we're not going to look at it because I already have it set up here. We're going to create a plan guide based off that statement. And what I really want to do is just, I want to take this away and I want to force it to use an index. So I can actually do that here by having our table hint, and then of course this is going to have to match what we have here on our table. But this is just kind of show you even a complex example of how we can use plan guides with SB execute, even with extra options that are in there that we want to be changed. So as we go ahead and rerun this, we can see that we're using that plan guide that we just created. So yes, plan guides will even work with SB execute SQL. So the key thing that you want to make sure is the parameters that you're using. So this over here, this needs to match the parameter list that has to be applied to your plan guide. So now that you have that out there, same thing, you could drop the indexes here, but the one thing I want to show you, which is kind of a big pain in the butt with plan guides, is if I just add a space in here, so the text is not going to match when it gets hashed. And because of that, it's not going to use the plan guide. In fact, you see different plan there. Go to properties, no plan guide. So one of the reasons why people don't like plan guides is they're a little hard to understand and even to get to use, because right, a single space there will make it not use the plan guide. So with that, go back over to our slides. So how does this get much better? And this gets better with SQL Server 2016 because there's a new feature out here called Query Store. And the same feature is actually also out in Azure SQL databases as well. And in fact, there's even a portal, which we won't go over here today, with some really cool stuff that makes this even better for you from a performance tuning standpoint. But the key thing to show here is this exact scenario on a more real-world scale, where a workload is constantly running, you can easily go to this report management studio, see that we have multiple plans, see which one is better, and then just force it to use it. So you don't have to worry about making sure that the text you have is perfectly matched up and everything like that. You can just click on a button and easily force it. It makes this a lot easier. So, go back. So we're going to go ahead and jump into the demo now. So I want to go ahead and make sure that we have no plan guides in here. All right, and then we're going to go ahead and look at our query store. So the first thing that we're going to do here is turn it on. And you could do that a couple of ways. We can do that here, which we'll do by running a statement. Or if you wanted to, and I'm going to go ahead and refresh the databases here, you could do it through the properties window too. So if you go all the way to the bottom here, you see Management Studio, you can turn it on here. But one thing I want to show you before we get started here, and I'll even refresh, if Query Store is not enabled, you're not going to see Query Store down here at all. It's kind of like a magic trick. The second here that we go in and we turn this on in Management Studio, and for today's demo, I want us to sample very quickly because we only have, about 15 minutes left here. We're going to sample every minute here. And I'm also going to kick off a little workload, which we're going to talk about in a bit too. But here, as we can see, if I refresh, I told you it's like magic. Query Store folder just automatically pulled up here. So once you have it enabled, you'll see it in Management Studio. You got a couple different reports that you can look at. So the first one that we'll go ahead and look at is just our top resources here. So in here, we're going to see that exact same statement that we have in our stored procedure. And I'm just going to go ahead and make sure that we have this set up. And you can see there's a lot of different options here on your report that you can figure out how you want to slice and look at this data. So for right now, we're going to go ahead and look, say, last 5 minutes. So we're going to see this as this is changing. And we'll talk about the little code here that we're running in this demo. So I am a DBA. One thing to let all our developer friends know, even though someone's a DBA, they actually might be able to write some application code. But here's this real basic demo here where basically I'm looping through 100,000 times. So in a way, this is kind of just like our nested loop that you see as an operator in SQL. I'm going to get a random number between 0 and 10. I'm going to print it out, and then I'm going to call the stored procedure using those values. So pretty simple. There's one little thing that's added here to kind of simulate us having our plan fall out of cache. If it's an even number here, then we're going to free out the proc cache too. So this will give us cases where the plan falls out, and then randomly, as you see this running, we're going to find cases here where we're going to free the cache, and then it's going to do it where ID equals 1, which is the 100,000 rows. Where if it's any other number, then it's just a single row. So as this is running here, and you understand how this works, this is just simulating some workload. We can refresh, and we see something very interesting that's a lot easier to see compared to everything we just did before, step by step looking at T-SQL. You have a nice graph that's showing you what's your big offender. You can change this over here based on whatever you want to focus or whatever your pain point is, like logical reads for right now. You can look at total, max, average, standard deviation. Here we have one that's jumping out to make this easier for us. The big thing we can see is that the execution plan is changing. So if we click, we can see exactly the statements here. In fact, if you want to compare the plans, we can click on them both here. And with one quick click, look at them both and see exactly how they're different. So here we can see we have our nice little nested loop here where the estimated row size is 1. This basically means ID didn't equal 1, it was something different. Where over here for plan ID number 2, we have our exact opposite here. So we can see plan ID 2, and we're going to estimate that, remember we had that many rows for ID equals 1. So pretty cool, you can see that all in one little screen. So when we started off, remember we just did the worst case, best case one time for each of the plans. Now we're just randomly throwing all kinds of workload here. And we're starting to see that this one, right now, our table scan actually looks to be better. And this kind of makes sense for the amount of data that we have. As this data changed and we add a lot more, this would change. But the whole point is we can easily click here, do forced plan, and this would actually force the plan in there. So we are going to use it now. I'm actually going to force the other one here by mistake. When I say by mistake, this isn't the one we would want to force, because you can see as we checked to force it, we now see our checkbox here. This is showing us that we're forcing the worst plan. And the reason why I'm doing that is because we have another report in here that we can use to find regressed queries. So I'm sure nobody watching this webinar has ever been in this scenario where they had a code release where they added some changes and performance got worse. That never happens for anyone. Well, a nice thing with Query Store here is we can identify these cases. So as this runs over a period of time, this will get pinned. So we're going to change the parameters here, tell this that we have 2 different time intervals to compare between. So we're going to say real recent. So we made a change in the last 5 minutes compared to what kind of history we want to compare that against. So as you see big differences here, that will show up in this report. So we'll go ahead and run this. And here we can see it's already pinned in here. Hey, here's a case where we made a change. This is worse. We want to focus on this because here we know something went bad unexpectedly. We can easily see this and make a change. So this is really helpful for people that are in environments where you're doing changes a lot, but it's also going to be super helpful for when you're doing upgrades. In fact, when I work with clients that are using SQL Server 2012 or lower, so before the cardinality estimator changed in 14, and they do an upgrade, we'll actually keep the compatibility mode on the mode that they're on for a while so we can bake in some plans, then during a plan time flip it, find cases like this where we find those few plans that are much worse, and we can tell it to force the good plan there. So it even helps with migrations for making that a lot easier. But so here's our perfect example here where we can see this is worse. Now we can go back here and say, no, let's force the good one. And then as we go back here, so we'll see it's forcing it back down, and over time here we'll start to see ones down here that are better. So this is going to be a great feature that every DBA or person who has DBA responsibilities and are looking at performance is going to want to use, because this allows you to take a task that takes really talented senior DBAs a long time to, 1, catch, 2, do your analysis, and then 3, force and continue to monitor. This is going to make that process so easy to almost anyone can go ahead and start doing this kind of work. So that's how the graphical interface here works. Some other things that you may be wondering is, what does this look like underneath the hood? So for example, what views or objects do we have to play with to get a lot more data than what we're just seeing through the interface? So the first query we'll look at is basically pulling a lot of this stuff together here. So here we can see that our text is here, our objects, we know this is the stored procedure, the hash, all that fun stuff in there, pulling it together. If you want to look at all the knobs you can play with to control how much data is collected or how often you're sampling to collect data, you can see all that to set that through T-SQL 2, even for the stuff that's not there in the GUI for you in Management Studio. So to drive a little deeper, we'll look at our plans. And so I mentioned upgrades. So this is data you don't see through the GUI, but you can easily get through T-SQL to where we can see, as this ran in here, what version we're using and what compatibility mode we're using too. So this is where it makes it real easy for us to go ahead, do the upgrade, put it on 16, have it on the old compatibility mode, flip it, and then we can know exactly the plans that changed because of that. And then also look to see which plans got worse and easily force them to use the good plan. So that's looking at the plan. One other thing for anyone that likes to, sorry, I think I'm jumping ahead of myself here. So here's looking at the query stored data in here. So this is a record for each query that's out there. So you can see when's the first time it came in, some average stats. And this is where I was jumping ahead, because if anyone is using Azure SQL Database, and you would love to actually figure out how is DTU calculated, well, there's this column over here, is Cloud DB internal query. It makes it easier for you to see what kind of system stuff is going on across your database there. So I did this for the virtual, for the cloud virtual chapter, and over there it's recorded, but I show you exactly how you can use Query Store to figure out the internal queries that are used to calculate DTUs. So that's a nice little added thing to go over there. And then here, if you want to get the actual text, you can pull it from here. You have all that information. And then we have our buckets here. So remember, when we set this up, I told do this for 1 minute because we only have a small amount of time here. That will show you your buckets here. So we can see as we run this, you can see that we've been collecting data, and that data gets aggregated here over every single minute. Obviously, the closer those two values are to each other, the little more impact that query store may have on your workload. So you definitely want to test this out. And then the last one here is just all the detailed data per bucket. So here we can see for each runtime we have for the plans per the time interval, how often did it run, and what kind of duration did we have. Same thing for I/O, CPU. And then the last thing we'll go over here is a very interesting way to help you use query store with workload tuning. So at the past summit last year, I did a full session over workload tuning. And one of the bottlenecks of this process is to do a lot of the analysis. If you want to drill to the query level, you have to have big traces running to capture data for you. Well, with Query Store, we could just aggregate this data here, sum across for the time that we're collecting, and you can easily get those metrics, store them, and then you could do the delta there. So for example, you have your baseline, maybe you change your procedure, you rerun your workload, you can then compare the values here based off your hashes to figure out what kind of improvement you got or if it made it worse. So if you want to see more about that, definitely check out that session out there at out on the past recordings. So with that, we'll go back to the slides here to wrap this up. So we did our demo. I gave you some more reference material, and that's pretty much it. So like I said, the PowerPoint and the slides and the code and everything will be up on my blog, so everyone can go out and get that. So if you're really interested in seeing how can I force good plans today, you can walk through that, and then also have all the SQL scripts to do that as well. And with Carlos, we'll turn it back over to you to go over any questions we may have.
Okay, just a couple of questions, John, but great session, very detailed, very good information. Really useful too, I think. You know, one question, you mentioned the slides and the demo code, and when do you think they'll have that up? Somebody's asking, I guess they're itching to get it, so do you think is that going to be soon?
Yeah, so I put this slide up just for everyone to know. If you go to my blog, johnsterrett.com, it'll be the first thing up on the homepage probably in an hour or so after this session, or after we hang up here.
Okay, so just in about an hour or so. Okay, great.
Yep.
Hey, one question I have here that I want to direct to you is, can regress queries show history of changes even if the SQL Server instance gets restarted?
Great question. So to repeat for the recording, if you restart SQL, are you still going to be able to get the request query info? And so the answer to that is it depends. So if you're just going and querying the DMVs itself, that data doesn't get persisted. So anytime you restart your instance, you throw that all in the trash can. If you're using Query Store in 16, that data is stored in the database itself, and there's thresholds you can set for how much space is dedicated for that too. Now, in the demo today that I went through, if we remember and we go through the code there, I'm actually taking that data and storing it in a table. So you could easily have a SQL agent job that does that, or in 2008 and up, you can use the Managed Data Warehouse 2, I think, to help you with a little bit of that as well. But yeah, so if you're just going off the DMVs, that's not going to be persisted. You're going to lose it. But if you're using something like a job to grab and store the data, you would then have it, whether it's your own built thing or something else, or even a vendor product.
Okay, great. Thanks, John. Hey, one more question about the slides and the demos. You said they would be on your blog. I mean, do you have a link, or should people just go to your blog and find it there?
Yeah, no. So here, if you go to if you go to just John, and if you can, Carlos, please throw this in the chat window for me.
Okay.
But yeah, if someone just goes to johnsterrett.com, it'll be the first thing you see right up there on the top. Just give me about an hour. It should be much quicker than that, but right after we disconnect here, I'll get that stuff out there for everyone.
Okay, sounds good. I think that was it. Not sure I think we've answered all the questions, and I think it was a very good detailed session, a lot of good comments. So thanks a lot, John. Really appreciate it.
Perfect, great. So if anyone takes the code and goes through it and you have any questions after you start using it, feel free to reach out to me, any one of these avenues to communicate. I use them quite a bit, and I'd love to hear from you and try to help you out.
Great, thank you, John. I think I'm going to stop the recording now.